So in question number 20, we're looking at 20a and it's asked us to factor fully. So we've been given a fourth degree polynomial, x4 minus 13x squared plus 36. So I've rewritten it down here. And what we can do is since this is a fourth degree polynomial, it's not really a quadratic, but it actually is. So if we take a look at this pattern of 4, 2, 0 as powers, we can think of this really as an x squared squared really is x4. And then we have a squared. This is of degree 1 and a constant term over here. And to see this a little bit better, we're going to do a substitution. We're going to let x squared equal a. And then if I replace the x squared in this line here with the a's, I end up with a squared minus 13a plus 36. And it looks now more like a quadratic. And so this factors normally as two numbers that multiply to 36 and add to negative 13. And it's going to be a minus 9, a minus 4. Two numbers that multiply to positive 36 add to negative 13. So there we go. Now, this isn't really fully factored because really we weren't dealing with a, we're dealing with x squared. So what I'm going to do then is I'm going to replace that x squared back into the a, so that a becomes x squared minus 9. And the a in the second bracket, I'm going to replace that one with x squared as well. And that's minus 4. So this is really what it looks like. We factored it as a quadratic, and we end up with this. Now, to factor fully, we have to recognize that each of those brackets still is a difference of squares. So we're going to end up with two numbers that multiply to negative 9 and cancel out are going to be x plus 3, x minus 3. And that will represent this bracket here. And then we're going to factor this into x plus 2, x minus 2, because again, that's a difference of squares. So this bracket here is going to factor into these two terms, and that's the whole thing fully factored.